Hi everyone, the question is let A1, A2, A3 be regions in xy plane defined by A1 where which has all the points x comma y such that x square plus 2y square is less than equal to 1. A2 has all the points x comma y such that mod of x cube plus 2 root 2 mod of y cube is less than equal to 1. A3 has all the points x comma y such that maximum of mod x root 2 y root 2 mod y is less than equal to 1. So we have to comment which set or which region lies in which other region. So basically we'll be plotting these curves by considering equality, and less than equal to we would deduce accordingly. So you can see the options clearly here. Now what about A1? If you consider, if you see carefully, it is mod x square plus root 2y, or rather mod root 2y square less than equal to 1. And similarly here you may say mod x cube plus mod root 2y whole cube less than equal to 1, and so that means mod x and mod root 2y are involved. If you see carefully, if you consider x square plus 2y square equal to 1, this is basically you may say is an ellipse x square plus y square by half equal to 1. So where the major axis is along x-axis and the minor axis is along y-axis. So this is 1, and this is, you may say, 1 by root 2. This is 1 by root 2. Yeah. If you see carefully, in A2 mod x and mod y are used. So if you plot in the first quadrant, in the other quadrants they will be respectively mirror images in x-axis and y-axis respectively. Why? Because if you put x to be minus x, mod of minus x is same as mod of x, mod of minus y is same as mod of y. So since mod of minus y is same as mod of y, and since mod of y is there, and instead of y if you put whether beta or minus beta, the value essentially of mod y remains the same. So that means the graph, the curve, the figure will be symmetric with respect to x-axis. Yeah, and just as in mod x, whether you put x to be alpha or minus alpha, mod of it would be the same. So since mod x is there, whether you put x to be positive or negative, keeping magnitude the same, the value of mod x remains the same. So the graph or the curve would be symmetric with respect to y-axis. Yep, plus x minus x. So here, if you plot it for a first quadrant, it will turn out to be something like this. It will bulge a bit more. Let me make it a bit better. So it will bulge a bit more when this cube thing is there. Similarly, you will have here. Okay, let me draw it first. Basically, what you have drawn in the first quadrant, in the second quadrant, similarly it will be mirror image. My bad. In the fourth quadrant, similarly it will be mirror image in x-axis. In the second quadrant, it will be mirror image in the y-axis, and similarly in the third quadrant, you may take mirror image either in x-axis or y-axis compared to whether you consider image of fourth quadrant or second quadrant. So I'll show you the final graph by plotting it rather than drawing it. Yeah. So and what about this A3? Maximum of mod x root 2 mod y is less than equal to 1. So this is equivalent to saying mod x less than equal to 1 and mod y less than equal to 1 by root 2. Yeah. So mod x less than equal to 1. So it will be something like this: mod x equal to 1 and x equal to minus 1. Yeah. In between these two lines. Yeah, and similarly mod y less than equal to 1 by root 2. So it will be something like this. Yeah. So if you see carefully, A3 is a superset of A2, which in turn is a superset of A1, because this region A1 lies completely, this region A1 lies completely inside the region A2, where A2 is this region in this blue part. So this region is coming a bit more, yeah. And A2 in turn lies completely in A3, which is this green part, inside this green part, this part. So A3 is the, so D is the answer. Let me show you the plot also using Desmos I have plotted. So you can see better now. These are the options, and this is this A1. Inside it is inside it is the region of A1, because less than equal to 1. Inside this blue part is region of A2, and inside this green part is this region of A3. So D is the answer. Thanks for listening.